Okay, so now we are ready to start defining the function to grow our tree. So let's get back into the C# component, and we are going to define this function down here. So we are going to define a void function, which means that it's not going to return any value, by the name of grow branches, and as input parameters we are going to define to specify the start point of our tree as a point3D object, then the direction as a vector, and the length of the first branch. So in order to define new branches, or better said new lines in Rhino, we need of course the start point, and we also need the end point that we are going to define right now. So what we are doing is, of course, first we need to define the data type of our new variable or new object, and now what we are doing is to take the start point, and we're adding a vector which is the length multiplied by the direction to this start point. So now it seems a bit strange, because basically we're adding a point and a vector, which are two different objects, and how is this even possible? So of course, if we take a look into the Rhino common documentation, so this is basically the point3D structure, and if we go deep down here, we can see that there are some operators defined, and in this case we're using this one, which means that it is actually possible to add a point3D and a vector 3D, and as a result we are getting a new point. So this is what we are doing here. And of course it could be possible to replace this point3D by the var keyword in order to avoid specifying the data type each time, because Rhino or C# is automatically recognizing that this guy has to be a point3D because we are defining this as a point3D object. So now that we have both points of our line, we can now define this branch or this line. And we are going to do it like that, with the line constructor that takes the start point and the end point. And now we can add this branch to our list of branches, like this. Branches add this branch. Okay, perfect. So now we have defined our function to grow branches. Of course, this is just going to work for the first branch, but we now are able to call this function from the run script method right here. But before starting adding new branches to our branch list, what we need to do is to clear any previous data that we may have into our list of branches from previous animations. So we are going to do it like this. Basically, if the iteration count is 0, which means if we have just clicked on reset, we are going to clear our list like this. So if you remember, since this is a global variable, we are storing here the data, and in order to clear it, we have to use this method here. And now we are finally ready to call our grow branches function. And as arguments, it's going to take, of course, the start point, and we are going to specify the input parameter origin for that. And we also need a direction, and for this, I'm going to use the static property z-axis. Sorry. And if you remember, in order to call a static property, which means a property which is common for all instances of this class, we have to reference the name class at the beginning. And now we need the length of the first branch, which is going to be 4 meters in our case. Okay, so we have already called this function here. I think we can now go back to Grasshopper. We can see that now it's working, but we are just drawing the first branch or the trunk tree. And if we click reset, we are actually drawing it again, but we don't see it because each time iteration count is 0, we draw the branch again. But anyway, this is actually working. Okay, so now if you remember, what we're going to do is to define a function to draw 2 additional branches at the end of each branch each time that we are running our script again. And of course, it would be really clever if we could use the same function each time that we are adding new branches into our tree. So what we need to do now is to implement it in our function how we are going to draw these 2 branches at the end of each new branch. So as you can see, these new branches make an angle of 90 degrees from each other, and their length is a bit smaller than the previous one. So let's define this. Okay, let's get back into our C# script. So we are going to start adding new branches here, and we said that we are going to add new branches until they are too small. So we're going to write this condition this way. Let's say if length is greater than 1, and remember that the length was this input parameter into this function. So in this case we are going to define our two new branches like this. So first we need the direction, and for that we are going to take this vector, this original vector of this function here, and we are going to rotate it by an angle that we already defined as a global variable, in this case 45 degrees. And we are going to do the same for the other branch. Let's call this direction 2, sorry. And we take the same vector, and now we define the angle as with a negative value, so that they make an angle of 90 degrees between each other. Okay, and now in order to draw these new branches, of course we could use the same constructor as before, but that could not be really practical. So instead what we are going to do is to use recursion, and that means that we are going to call the same function in which we are currently now. So in this case we are calling the function grow branches. So it seems a bit weird at the beginning probably, but basically we are using the same function with new parameters, in this case with the end point instead of the start point, so that the new branch is added at the end of the original branch that we defined here. And we are going to take this rotated direction, and as length parameter we are going to draw this branch a bit shorter than the original one. So that's for the first branch, and now we have to do the same for the second one. Let's take direction 2. Okay, everything looks nice, so let's actually test if this is working. Basically it's working, but the problem now, I mean it's not a problem, but we are defining all the branches at the same time inside this function, the same time when we call this function, and it would be really nice if we could start displaying these branches in some progressive way, so that we can end up with some nice animation as we saw at the beginning.